Okay, we're going to cover the chemistry of life starting for Unit 2. I hope everybody has read, or at least by the time you get to your test, that you have read and studied the unit. Most of you that are watching this will have completed your test over Unit 1, and if you didn't read, you will absolutely learn why it is important to do the reading. The reading and the slides go together, but the reading is more in depth, so the test comes from both. Also, like I told you guys, you have to do critical thinking on these tests, so you have to pull out your brain and make it work. So the chemistry of life, actually most of you have had chemistry by now, yes? Most of you had chemistry. Some people chose IPC, but even in IPC you would have covered a lot of this material. We're not going to spend a ton of time on it, but it is important because our body functions based on its chemical makeup. All the atoms that are rolling around in our body, if we didn't have the right ones, then we would be in trouble. All living things have about 26 elements that make their processes work. Mostly we are carbon, oxygen, hydrogen, and nitrogen. That's almost every organism, every living organism is mostly carbon, hydrogen, oxygen, and nitrogen. Those are the six of the most important 26 elements. What are some other things that we have? Anybody know the other things we have in our body? Phosphorus, potassium, calcium. Any of you that have been having leg cramps? Sodium. Muscle cramps. Sodium, potassium, calcium are really important. If your calcium level gets too low, your muscles will relax to the point where you feel like you can't move. You know, everybody's had the flu at least once. You know, the part where your fever, or if you've been sick where you've had a fever that was kind of high. You know, when your fever's high, you just feel like you can't even move. You're so weak. And when your calcium gets low, people feel the same way. So just because carbon isn't, hydrogen and oxygen or nitrogen are important, that doesn't mean that the other elements are not. So atoms are the smallest basic unit of the body. We all know what an atom is. It's made of electrons, protons, and neutrons. And either they are neutral or they are have a positive or negative charge. The three substances, we talked, like I just said, protons are positive, neutrons are neutral, and electrons are negative. I could always remember these because positive is P and protons start with a P. Neutral means negative, neutral and negative both start with an N. Hopefully you guys already know all that. Elements are substances they're a pure substance, they're not a combination. So everybody learned when you were in chemistry, did you use the periodic table? Yeah. So you learned what elements were naturally occurring in the body, which ones were found outside the body and other places. So whenever you learned about carbon on the outside of the body is the same as carbon inside the body. You guys learned about atomic numbers. So I'm not going to make you guys learn a lot of atomic numbers, and I'm not really going to make you do a whole lot of equation solving. Aren't you glad?
I didn't feel constricted to that.
Well, what we will do is figure out how sodium bicarbonate, how sodium bicarbonate in the body is important, and how the body breaks down, takes your sandwich that hopefully someone's having for lunch, and how it breaks it down. We'll talk about the different enzymes and the different reactions that the body goes through so that it can take nutrition and air and all the things that we need to absorb from larger molecules to make them smaller, and sometimes from smaller to make them larger. Atomic number is the number of protons. The atomic mass is protons plus neutrons. I probably would remember that. The atomic mass is protons plus neutrons, and an atomic number is the number of protons. What do protons make? If you have more protons than electrons, what does that make? The output. Makes it positive. Do you know one element in your body that's positive? I do not have a periodic table in here, but can you think of one element in your body that's positive?
Oxygen.
oxygen's kind of neutral. But sodium is a positive ion. Calcium, or chloride is a negative ion. So what happens when you eat salt? What is salt when you take it in? It's neutral. Okay, so those are the
Oh, I know those.
the elements, the symbols for the element, and these are things, especially on the left side, those are things that are definitely found in the body. Some of them on the right side are found more in air, or in things we absorb or take in. Is iodine important to us?
I think so.
If you don't have enough iodine, so iodine is not something our body can make. We have to take it in. Iodine is what makes your thyroid work. And if you don't get enough iodine, where do we get iodine from?
I'm taking iodine.
You've taken it, and we also give it in a contrast form for X-rays, CTs, IV and PO contrast with iodine. But salt is how we get it. If you eat table salt it has iodine added to it. Also shellfish.
I love shellfish.
So shellfish also are naturally occurring iodine.
What is shellfish?
Shrimp, crab, lobster.
Stuff I don't eat.
Yeah, those, things I don't eat. But we need some of all of these elements in our body. So there it is, where hopefully you can read it a little bit. Now, isotopes are elements with different number of neutrons than a stable element. Isotopes are important. Iodine can be a radioactive isotope. That's one of those things that we need, but we also can use it to treat things. When they are doing a thyroid scan to see if your thyroid is working, they literally give you a radioactive iodine pill to swallow. You take it, they scan your thyroid, you wait about 4 hours, they scan your thyroid, then you go back the next day and they scan your thyroid again. About 7 days. No, it's a small enough dose it won't hurt you. But it will make your thyroid glow where they can tell if it's functioning properly or if it's functioning too much, or if you have different kinds, if you were to have like a tumor or some kind of nodule on it. Radioactive isotopes have an unstable nuclei. They break down at a known rate, which is why we would give it to you to do different kind of studies. And also why we give it IV and PSPO contrast, because it does stay in your body for a little while. When you get CT scan or you get MRI or you get fluoroscopy, which is where they're looking at the belly on a screen. When they're doing that, they do that so it shows up well. It glows on X-ray equipment or diagnostic equipment, but then you're going to get rid of it. Your body is going to get rid of it in the form of a bowel movement or urine. And that way, but it does stay in the body for several days. Someone who has IV contrast with iodine that's a diabetic that takes metformin, you have to not take your diabetic pill for about 2 days, because if you do, the medication itself along with that iodine will shut your kidneys down. So there are effects of taking some kind of having contrast given to you. They usually give you things to take insulin for. There are just certain diabetic pills that cause that, but it definitely will make you have a negative reaction. And I've had patients take it and then have to be on dialysis for a few days.
Is there like a certain spot that you have to give your insulin? Because I've seen people do it on stomach. I've only seen people do it on stomach, but can you do it on anywhere in your body?
You want to give it in a place where there's fatty tissue. So it can be given in the abdomen, it can be given in the back of the arm, it can be given in the outer part of the thigh.
I was thinking that like they have to be close to the pancreas or something. What happens if you like miss a dose or something?
Of insulin? Yeah. Your blood sugar goes up. And it really depends. Type 2 diabetics sometimes can monitor their diet close enough and really kind of stay away from carbs, and they'll be okay without their metformin. Sometimes we can give them an alternative medication, but usually we just tell them to give them a a short supply of insulin for a couple of days, and they do that because insulin is absorbed directly into the bloodstream.
I was listening to when people can like take those little like those balls like we did last year and we like, or else we where it already comes in like a pen.
The pen comes both ways. So you can get insulin in a pen, or you can get it in. You can draw it up. Some people get it in a vial, a multi-dose vial, because it is cheaper, and that's what their insurance pays for. The pens are really good for people with rheumatoid arthritis, because insulin needles are really tiny, and that pen is bigger, and they can dial it. They just have to be able to see well enough. Then they basically just stick it wherever they're going to give their insulin and push the top of the pen. No.
So you can't take like pills and stuff.
You can liquid insulin, no. And the pills that they give you are for type 2 diabetics. They're not for an insulin dependent diabetic. It's a type 1, like a childhood or someone who's developed insulin when they were young. Their pancreas will produce no insulin at all. People who have type 2 diabetes, they actually will produce some insulin. Their body has had one or two things. Either their islet cells, and when we get to an endocrine system, we'll talk really about this a lot. Either their islet cells, or they're called islets of Langerhans cells, they will either produce just very little insulin, which is not enough for what they eat, or because they've spent a lifetime eating high carb, high sugar, high fat diet, their body is resistant to their own insulin, so they have to actually give themselves more. Those are the most dangerous type of diabetics, those insulin resistant diabetics, because they're giving themselves a huge amount of insulin.
Can you give yourself too much insulin?
Yes, you can, and you can go into a coma. It'll drop your blood sugar to the point that you can go into a coma. Here's a good example. I love my husband, but sometimes he will eat and then determine how much insulin he needs to give himself based on what he ate. The other day he ate, what did we have? I can't remember what we had. I can't remember exactly what we were eating, but he gave himself too much insulin because he didn't realize that it didn't have as many carbs, because I had made it with almond flour and made it a little different to be healthier for him. Well, he gave himself, it was something fried we were having. I think maybe it was pizza. So he gave himself too much insulin. About 2 hours later, he looked at me and he goes, "I don't feel good." I said, "You don't look like you feel good." And their pupils will kind of dilate and they get real shaky, and he gets real clammy and swimmy. And he couldn't even check his own blood sugar. He was so shaky and weak, and his brain wasn't functioning. So I checked his blood sugar. His blood sugar was 32. It took literally a soda, a candy bar, a sandwich, chips. What else did he eat? Stuff I could get into him. And something else to get his blood sugar back up to 70. Because
minimum blood sugar.
yeah, at 70 he can function. It finally got up to about 95 with all that food. If he had eaten that with a normal dose without giving himself any insulin, blood sugar would have been 600 or 700. Okay, so moving on. We use a lot of those different kinds of radioactive isotopes for testing, like I said. Molecules are the smallest unit of a compound. So what is a molecule? I mean, when you think about a molecule, what do they teach you in chemistry would be a molecule? So if an atom is one thing, what would a molecule be? Two atoms connected, maybe two or more, right? So a compound, I forgot to roll that up. It's a substance that has two or more elements that are with a fixed ratio. Their properties actually may be different, but they're bonded together. Okay, so bonding patterns. Who remembers their bonds?
Covalent bond.
Covalent. What else is there?
Ionic.
Ionic. And okay. So when atoms gain or lose electrons, then ions are created. So like I said, sodium is positive, chloride is negative. So when they bond together, it makes a neutral. It makes a neutral element, which is why if something's burning your skin, you can put salt on it. If it's an acid kind of burn, you can't put salt on it. You can pour milk over it because milk is kind of a neutral. It's as close to neutral as we can get on the pH scale.
Salt wouldn't burn.
It is neutralizing the acid. Yes, it irritates your skin a little bit, but it also helps neutralize certain acids. Hydrochloric acid, not so much, but it will burn the skin, yes, but it also will neutralize the acid to prevent it from eating down further into your skin.
So it's gonna hurt either way.
It's gonna hurt either way. Yeah. Okay, so ionic bonds are the attraction between two opposite charges. So ionic bonds are positive and negative, right? So that is salt. So we have sodium that's negative and it's picking up a positive ion, or sodium is positive and it's picking up a negative ion from chloride and they're connected together with an ionic bond. Covalent bonds are what we see the most often, right? That's when atoms join together through electron sharing. Two atoms share one or more pairs in the outer shell of the electron. Is this all coming back to y'all?
This is sophomore year since I've had this class. I had it last year, but I didn't really learn anything then. Studied. So
See, that's an excuse. So here's my thing. I took chemistry from someone who was brilliant. She was brilliant, but could not teach to save her master buddy. I mean, this woman, she was phenomenal. She's passed away now, but she could teach you if you went in and sat down with her. But she could not teach a class. And so basically, she would give us a chapter to read. She would work a few problems on the board, stoichiometry, things like that. She'd work it on the board. Then she'd sit down and tell us to finish the rest of the stuff in the book.
that's pretty to the T.
But I needed to learn. And so I would go in and I would either ask other people for help, and if they couldn't help me, then I would go see her. So someone not teaching you is not a reason not to learn. Okay. Oh, sorry. So there we have, what is CH4? Carbon with 4 hydrogen elements. So remember 4 hydrogen elements. Carbon with 4 hydrogen elements. So we know carbon has 4 pairs of electrons, right? Yes. And hydrogen has 1, yes. Carbon has 4 electrons around the outer shell, and then hydrogen has 1, right? So they're gonna pair up. So we are not going to do bonding in this manner. Now I will tell you, if anybody's going into healthcare in this room, you will take organic chemistry. Remember the bonds. Remember why they would bond together, and it will save you with organic chem, because you need to know whether they're polar or non-polar. You need to know why they would be attracted to each other, like why the ionic bonds are attracted to each other, why covalent bonds are different from ionic bonds. So when covalent bond atoms share electrons equally, so when oxygen is shared by 2, they each share 2. What is CO2? That one's easy. That's carbon dioxide. So when we get rid of carbon dioxide, or when we do keep some carbon dioxide in our body, we should have less than 20 deciliters per. I forgot, it's deciliters per something.
What is CH4?
Deciliter is 10. Or 10. So deciliter would be between. What is it? So it's deciliters per nanogram. I think is what it is. It should be less than 20 deciliters per nanogram. I don't know. It's just the way that the blood machine runs it and how they measure it.
Maybe you should teach chemistry. We never learned that. What's CH4?
CH4 is see, I actually had it wrote down so I would remember, because I didn't remember from chemistry. CH4 is, somebody Google it. I can't remember.
We don't have our, we don't have phones.
You got a Chromebook right there, open.
Go Meyer.
So polar bonds, they share unequally. They're not sharing the bonds equally. Carbon dioxide shares it equally. Water does not. So it's unequal. What is it? Methane. Yeah, that's what methane is. What happens whenever someone farts. That is methane gas. Or if you're around lots of cows, they burp.
Yeah.
When cows burp, or when they're chewing their cud and their stomach is ruminating, changing food from one chamber to the other, then the gas that they produce is methane. She doesn't hate you. She's just
None of the other ones do that. Except it's dog farts methane.
all gas is methane. All byproduct of the bowel of anything is methane.
Dog farts are the worst. Oh my god. Then when they're silent, how do they crap themselves?
Right?
Like my dog, she will like have the silent ones, and she'll like look up and see if I like notice it, and it'll hit me, and I swear I want to throw up every time. And I'm like, if you just crap on my freshly washed sheet, I will kill you.
My dog will pass gas and then she will get up and move.
Yeah, that's what it is. She goes to the bathroom, and she'll be like,
No, she'll just get up and move. Like she'll be behind the chair where you're sitting. And she'll get up and move over to the other side of the room. She's a hot mess. She's old too. So electrons that are shared unequally between two atoms create a polar bond. Non-polar bonds have equal sharing. So if you think about it, they're kind of like a magnet. If you put two magnets together, they'll connect on the right end. But if you flip them around, they're not going to connect equally. So, but polar bonds, they're going to attract that. Maybe they're going to attract the atoms to one side of the shell, not sharing them equally. Hydrogen bonds, that's the one y'all forgot. Hydrogen bonds are weak bonds, but they're important in the chemistry of life. Our body is made up of many covalent and hydrogen bonds. We don't have near as many ionic bonds. We actually, those are where our minerals are, and we have to usually get minerals from somewhere else. But our hydrogen bonds, they're weak, but they're very important to life. They are charged regions on water molecules that attract to the opposite charge region for nearby molecules. So our cells are full of cytoplasm, which is water, right? When we have, when say blood is flowing through the body, and we need to bring fluid into a cell that's dehydrated because y'all ran too much today. And you sweated a whole lot, and you were thirsty, and your body told your brain, I need water, I need something to drink. So what needed to happen is the sodium and potassium that you lost by sweating, the water molecules that are inside the cell were smaller than they needed to be. So they were actually notifying other cells, to other parts of the body, to open up the channels in your, the sodium, potassium, calcium channels in your body to let more fluid come in. So water will attract other nutrients and other particles whenever it needs it. When it doesn't, those channels cut off. So your sodium, potassium, and ion channels are important for just about everything we do. All skeletal muscle movement is related to that, including your heart beat and what else? Brain function. Brain function. It controls everything. So there's an example of a hydrogen bond. So see a covalent, with a nonpolar bond, they're actually there, but they're not just snugged back up. They don't always necessarily become, they're easier to break apart. Nonpolar covalent bonds are easier to break apart. Why? Non-polar covalent bonds are easier to break apart. They don't need as many enzymes to break them down. But polar bonds are harder to break apart because of the proximity and the amount of attachment. And they're unequal, so an enzyme can go break that down. What time is it?
We have like 2 minutes. Yeah.
We will stop. No, we need to start law today.
So we're not running ankles because the first group hasn't got to yet. What was that? We normally mix everything. That we had, because I have no idea.
She gave us,
Second half does, second period does too.
she gave us 3 pages of work that are on white paper, and then it was 1-